Hello, I'm Alan Fulton, University of California Irrigation and Water Resources Advisor, working in the northern Sacramento Valley in the counties of Tehama, Glenn, Colusa, and Shasta. Welcome to this tutorial on using our weekly crop ET reports. In this particular issue, we'll talk about measuring tree water status directly. Today, we can assess tree water status directly as opposed to indirectly with water budgeting or soil moisture monitoring. There is a lot of ongoing investment in the plant-based measurement methods to advance it into the future. In this short tutorial, I'd like to talk about the current tool, the pressure chamber, that we use, its basic operation and interpretation of field data, and I'd like to review with you an advanced method of interpreting field measurements. So for the moment, the gold star for measuring tree water status and using a plant-based approach is the pressure chamber. Why? It measures the tree, which is what we care about. When we use the pressure chamber, we are assessing tree water status amidst the soil-plant atmospheric continuum. We know that when a soil has been recently irrigated, if you have a soil moisture tension sensor device like a tensiometer or a watermark sensor, that you will find that it will read approximately minus 30 centibars, that is 1/3 of a bar tension. In the roots, under that same condition, we'll most likely experience about a 4-bar tension. In the trunk, the tension will increase to about 8 bars. In the scaffold xylem, about 8.5 bars. I've highlighted this in red because this is typically what we are measuring with our midday stem water potential technique when we cover a leaf on a lower limb in the shaded area of the tree. Inside the leaf, the xylem tension will be about -9 bars. Inside the air spaces of the leaf, about -12 bars. At the edge of the canopy surface, outside of the leaves, the water tension will be on the order of -70 bars, and about 3 feet above the canopy, we can expect to see the water tension to be about 95 bars tension. It is this negative tension from the soil to above the tree canopy that creates a vacuum or a suction and drives the water use by a tree. And it is our pressure chamber technique that allows us to get some sense or a measure of the stress level and tension in this process. This is a cartoon of a pump-up pressure chamber, actual pressure chamber that is available on the market for about $1,500. What it shows here is a sample leaf inside the chamber, the sealed chamber. The leaf is inside a foil bag. It was covered while it was on the tree and before it was excised from the tree. It was covered for about 10 minutes, then excised, put in this airtight chamber. Then this is using a bicycle pump to add about a 1/2 bar pressure to the chamber with each pump. And we increase the pressure inside the chamber until water is pushed from the leaf out the cut surface of the stem, sticking outside of the chamber, and until we can see the end point on that cut surface. When we see the water exuding and covering the cut surface of the stem, we measure the pressure on the gauge, and that is a measure of the stress level that the tree is experiencing at that particular time. This is what it looks like more in the field. This is an almond tree. You see a single leaf covered in a foil bag, hanging from the tree in the shaded area, approximately shoulder height, chest height, something like that in the tree canopy. This bagged leaf hangs there for at least 10 minutes to equilibrate, allows this leaf to equilibrate with the rest of the vascular system that is conducting water up the tree to give us a measure of the tree water status and to avoid getting a indicator of the individual leaf measurement. We're interested in this tree water status of the larger canopy area. So once the bag leaf has been on the tree long enough to equilibrate, it is cut from the tree, is quickly placed into the top of the lid of the chamber, and then closed in the chamber and sealed. When the bagged leaf is inside the chamber, all you see is the cut stem protruding out the top of the chamber. And then we begin to put pressure, add pressure to the chamber, and we're looking for when the xylem water covers the cut surface of the stem. And then we're measuring the pressure on a gauge, in this case, a digital gauge, and noting it in our records. So a little bit about the basic interpretation, the simplest interpretation. I'm going to only discuss it in relation to almonds. I will end the presentation with some references to other information to help with walnut and prune. In the case of almond, we don't often see pressure chamber measurements of less than 6 bars on the pressure chamber measurement, only on very cool spring and very wet orchard conditions. Typically, we will see a range between 6 to 10 bars or -6 to -10 bars tension on the pressure gauge during the months of March, April through mid-June. These are indicators of low stress conditions, fully irrigated conditions, and tend to be conditions that will promote the most shoot growth and canopy development. From 10 to 14 bars on the pressure gauge, or -10 to 14 bars tension, this is considered mild to moderate stress and may be appropriate in the latter half of June leading up to hull split, especially if we're interested in managing hull rot and achieving uniform hull split across the orchard. During hull split, we recommend a -14 to -18 bar level on the pressure chamber measurements. This has been shown in research to help control hull rot, other diseases like alternaria, and speed up hull split, leading to an earlier, more uniform and efficient harvest. Once we go above 18 to 20 bars, we are transitioning into moderate to higher crop water stress levels, and we would prefer to minimize the time that your orchard is in ranges that exceed 20 to 30 bars and definitely more than 40 bars tension. Once you get in these ranges of 20 to 30 bars, you can expect to see some modest levels of defoliation, and above 30 bars, extensive defoliation of your orchard. We definitely want to try to avoid this if we can, leading up to post-harvest irrigation so that we can be more effective at controlling stress, irrigating, and encouraging the development of the buds for next year's crop and yield potential. Now I'd like to review with you quickly and introduce you to an advanced method of measuring and interpreting your midday stem water potential levels. So I want to raise the question, if I have a day that the temperature is about 90 degrees with 30% relative humidity, and I have a day the temperature is around 105 degrees with a strong north wind and only about 10% relative humidity, and in both conditions I go out in this orchard and I measure with my pressure chamber a tree water status of 11 bars, would like to raise the question, which orchard condition represents more crop stress? Or are they the same as the numbers would suggest? To explore this question, I want to remind you that we have developed through research baseline stem water potential tables. Also, we have available on the UC Fruits and Nuts website, UC Davis Fruits and Nuts website. There is a calculator to help you calculate this baseline stem water potential. But what it points out is that on a hot day of 105 degrees, high wind with low relative humidity, we might expect that because of the strong environmental conditions, that we might expect that the lowest midday stem water potential that we could measure in that environment would be around 12 bars, 12.3 bars to be specific. Whereas on a cooler day, a day that is 15 degrees cooler with 20% more relative humidity, we might be able to measure a well-watered or fully irrigated tree water status condition of around 8 or 8.2 bars. And so our pressure chamber measurements are a function of our environmental conditions at the time of measurement, as well as our irrigation management. So with this in mind, this information in mind, which of these 2 days does this 11-bar measurement represent a higher tree stress level? Well, let's examine it more closely. So I showed you in the previous table, at a 95-degree temperature with 30% relative humidity, our projection of a fully irrigated stem water potential level would be 8.2 bars. So if we compare the 8.2 bars to the 11 bars actually measured in the field, this suggests that on this day, the orchard was 2.8 bars below baseline, or more stressed than the fully irrigated condition. We look at the warmer, windy day. We see that our baseline, thinking back to the previous table, we're reminded that our baseline stem water potential was 12.3 bars, but we measured 11 bars in the field with the pressure chamber. This actually points out that we are on that given day, in those conditions, we were 1.3 bars over baseline. This would indicate that the orchard was recently irrigated, the conditions are fully irrigated, and actually surpassing what we would expect for fully irrigated conditions. So when we raise the question, which of these 2 orchard stem water potential measurements indicated a more stressed tree condition are due to not having enough water, it would be this cooler day with a higher relative humidity. This day, the 11 bars on the hot, windy day suggests it was the best we could do in terms of creating low orchard water status conditions. So again, the scenario on the left represents a condition of more tree stress related to irrigation water management than the scenario on the right. I hope this tutorial has helped you think a little bit about the pressure chamber, how to use it, and how to interpret the numbers. I used Allman as the quick example. Bring your attention to the Sacramento Valley Orchard Source website. You can look, explore, search under our manuals. You'll find a series on stem water potential that I have written along with my colleague Luke Milliron. And in this, we take you through a number of different topics, and we give specific interpretation guidelines for walnut, almond, and prune. Thank you for joining me in this tutorial.